All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria covnets module. Let's have a look at what we went over today. Yesterday, if you recall, I'm not sure if we did get around to it, but I'm pretty sure we did. The last thing we went over was padding, and today we're going to pick it up where we left off. So another hyperparameter we could look at is the stride. Note, we've been looking at all the other hyperparameters so far, which include the input size, padding, and the kernel size. Basically, the stride determines how many pixels we move through at once inside our input with our kernel or filter. Let me actually go up and show you what that looks like, so I can show you a better visualization. So remember here, this is our input of what is this here, 4x4, and we had a kernel size of 3x3, so that would be 1, 2, 3, 1, 2, 3. So right now, our default stride side is set to 1. So what that means is we would move just one space at a time every time we make a move. That's either left or right, up or down. We would stride just by 1. That's what that means. That's what the stride is. It determines how many pixels we move all at once. So instead of moving, like say we had a stride of 2, instead of trying to move like 2 pixels, even though we couldn't because we have a 4x4 and a 3x3 filter, we wouldn't have anywhere to go. Just for example, I'm just saying, what if we had a 2x2 filter here with a 4x4 input and we had a stride of 2? We would go from here to here in one movement because we would have a stride of 2, meaning we would move by 2 pixels instead of the default 1. So that's what the stride is. The stride determines how many pixels we move all at once. Okay. All right, the default stride is 1, which means that our kernel filter will move 1 pixel left or right, up or down at a time inside of our input, like I just explained. The stride also affects the movement of our kernel filter up and down strides also. That's the same thing. I don't know why I put a note there. Increasing the size of our stride actually reduces the size of our output and hence reduces the amount of information we extract from the inputs. That's because with the, let's go back up so I can show you again. So again, let's say we had a 2x2 here as our kernel size, and this is our 4x4 input. We go from here to here in just 2 strides because we're not going to cover 1, 2. We're just going to cover both of them in 1. We're cutting out information. We're basically cutting out this information block here and going straight to this one here. Even though it is going to be encapsulated inside of our kernel, our input is still just going to be one movement, which is going to reduce the outputs we have. So this would be a 1x1 instead of a 2x2 because we're not moving 2 strides anymore. We're only moving 1 stride. So that's what that means. So if we had a 2x2, if we had a 2x2 kernel and a 4x4 input, and we moved from here to here in just 1 stride, that would give us a 1x1 instead of a 2x2. We wouldn't be moving 1, 2 anymore. We would be moving just 1. So that's why it reduces the output size. So in general, we get better results by working with smaller kernel filters and smaller stride values. This is because we are able to extract more information from our inputs this way. Generally, the kernel filter size of 3 is used in practice with a stride of 1, meaning that's the default size. So the default size of a filter or kernel is usually 3, and the default size of the stride is usually 1. Using padding is always optional. So the padding is going to be 0 unless specified otherwise. And the new formula for when we do decide to use padding is as follows. We have without put equals within or with input take away filter plus 2 times the padding plus 1 divided by stride. And the plus 1 actually goes here. Sorry about that. So the plus 1 doesn't go there. It actually goes here. So to better read that for you, let me save that. It'll be the width output equals the width input, take away the filter, plus 2 times the pixel size, divided by the stride, plus 1. And I'll have that here. So this can be read as width output equals width input, take away filter, plus 2 times the pattern, divided by the stride, plus 1. So for example, let's say we have an input size of 6. That will give us 6 minus a filter size of 3, because that's the default filter size we're going to use. So it's going to be 6 minus 3, plus 2 times the pattern of 1. So the default pattern size is 1. So 1 times 2 is going to give us only 2. So 6 take away 3 is 3, plus 2 is 1. And then we're going to divide that by the stride of 1. So what's that? 5 divided by 1 to give us 5, plus 1 to give us 6. Let's go over that again a little more slowly. For example, let's say we have an input size of 6. That will give us 6 minus 3, which will give us 3, plus 2 times the padding. So the padding is 1, so 2 times 1 is 2, plus 3 gives us 5. 5 divided by 1, which is the stride, will give us 5. Plus 1 gives us 6. Our answer should be 6. That's how we obtain our width out size when using a new formula, or our width output size by using the formula. Now, we did take a lot more notes and we did go over a little more things this morning to get a little more understanding, but I'm not going to dive into that right now. I don't want to get you guys a little confused. I do have a handle on everything and I am moving along fairly well, and I do have a grasp on everything I need to have a grasp on at this point. But as always, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.